Hello everyone, welcome to the Nucleus Annotation Project. This is Mohamed Amgad. I am a PhD candidate at the Department of Biomedical Informatics at Emory University School of Medicine in Atlanta, Georgia, in the United States. I received my MD from Cairo University in 2016, and I'm very glad to walk you through the various details of this project and to basically introduce you to this effort. I work under supervision of Professor Lee Cooper, who is an associate professor here at Emory University, and I am very glad to that you agreed to be with us on this project. We really appreciate the time, and we appreciate your willingness to contribute to science, and we promise you that your efforts will be well appreciated in terms of outcomes and things like authorship and attribution, recommendation letters, etc., etc., etc. So Dr. Lee Cooper can talk more about this, at a later time. I just want to mention that a previous version of this project for many of the people who are joining and who are not continuing from the phase one of this project, there was a previous version of this project that where we annotated histologic regions. So instead of annotating individual nuclei, basically annotating kind of broad regions of histology. Which was actually very successful and is now almost published in a very reputable journal in our domain in bioinformatics. And also, beside publication, the previous version of this project was really nice in that we really formed a very nice team. A lot of non-pathologists learned a lot of new pathology, and many people got recommendation letters and got accepted into programs based on work like this and so on. So it's good for us, it's good for you, and I really look forward to working with you. So let's get started. So before anything, let me make an important announcement or an important disclaimer. Please, please, please do not start annotating anything. Do not think that you will learn along the way, so to speak, without watching this tutorial from the first minute until the very last. Please pay attention to details in this video. There are very important details that I'm going to mention, especially things related to naming conventions, spelling, and things that can seem very trivial but are actually a huge pain in the backside for people who do the analysis on the data or the study coordinator myself. Also, make sure to check the Slack group every single day for updates. You can, make it your homepage. You can, just make sure that the Slack group is regularly followed. In my case, I make it as one of the startup pages on Google Chrome. And we also have something called an annotation rules document, which basically just outlines a set of rules to adhere to during annotation. And I would like you to always have that open while doing annotations and to look at that document before doing any annotation. So I'm also going to walk you through some of the stuff in this document in this presentation, but also make sure to look at it regularly because that's what's going to be updated. All right, so let's go through some general rules. To begin with, like I already mentioned, we have a Slack group, wsiannotationnucleus.slack.com. If you remember, the old group didn't have this nucleus in it, right? So make sure that you join the new group. There is an invitation link in the old group that you can click. You can also email me directly if you can't access the group or if you have any problems, and we can resolve it together. Again, the introductory meeting is this one. This is where I will be mentioning everything that you need to know in order to start annotating. But like I mentioned earlier, there's a Google document that I continuously update with rules. This is a dynamic project. Things change along the way as I see that people are confused about certain things, or that that maybe I need to change something. So please, please, please always take a look at this document regularly. Read this document at least once in detail before doing any annotations. Okay, so I cannot stress that enough. This is extremely important. All right. So what do we expect in terms of quantity from members in this project? So there are two types of slide sets. There's what we call the core set, which is basically 4 to 5 slides containing many fields of view. So FOV stands for field of view, which is basically a very small area that you can annotate. So it's very small, like 256 by 256 pixels, very small. So each person from the non-pathologists will have, or the junior pathologists will have 4 to 5 slides to annotate completely. You will also have 3 evaluation sets, each containing 5 slides, and each slide containing 6 fields of view. And this is this evaluation set serves a different purpose from the core set. So the people who were with us in the previous iteration of this project know that the core set is annotated in a kind of collaborative fashion. So for the core set, you you make annotations, you share with the senior pathologist in the group, or other people in the group, your questions. They answer your questions, then you go back on the core set and make corrections and so on. The evaluation set is different. The evaluation sets are basically things that we want to use to measure interparticipant discordance. How different are people from each other if they don't receive any help? So these sets, and by the way, these contain much fewer FOVs. They're just meant to as a probe of how different people are from each other, how do different algorithms compare to each other, and so on. So the core set basically is different slides. Every person has 5 slides that are different from every other person. Whereas the evaluation set, it is the exact same slides and the exact same fields of view being done by every single person, whether non-pathologist, senior pathologist, junior pathologist, everyone. And again, the purpose of this is for quality control, and also this is going to have an extremely important role when we want to publish our work. So make sure that you really annotate the evaluation set just like you do the core set. Unlike the previous iteration of this project, everything except for the first evaluation sets are not new annotations. They're actually going to be corrections on top of some existing computer annotations. And of course, these annotations are actually pretty bad. These computer annotations are pretty bad, because if they were very good, then we wouldn't need your annotations, right? If we had data that helped us already make a computer annotate slides and say this is a tumor, this is lymphocyte, etc., then we wouldn't really need that data. So the existing annotations are actually kind of very poor, but they will provide some value, as I will mention later. So they are useful and they do provide value, but they're not exactly the best annotations out there. So what you will be doing most of the time is correcting those. Now, as people from the previous iteration know, we have 3 tiers, or 3 categories of participants. We have non-pathologists, or NPs, junior pathologists, or JPs, and senior pathologists, or SPs. Non-pathologists are expected to complete all slides in the core set and the evaluation sets, and they do it in order, okay? So you do core set 1, evaluation set 1, evaluation set 2, evaluation set 3. You will have 3 evaluation sets, but you may have, I'll get to that later, but basically there's 3 evaluation sets, okay? Now, this is extremely important. Um, Everyone who participates in the project and does the full workload will get, once in the future we write this up as a publication, they will get authorship credit, okay, and other types of credit. No, there will be other opportunities for getting credit for this. However, it is very important to note that you need to finish the full workload in order to get credit and attribution for your contribution. Okay? There's no exceptions to this. So before you begin, look at the workload and know that you need to finish this in order to get attribution. Now, the workload is not really that big. You need at most 2 weeks of work at maybe, not 2 weeks, maybe 10 days of work at 1 to 2 hours per day, I think. Just probing, just from what I've seen. So if you can give that amount of time, and the project needs to finish within maybe within maybe 2 months, so maybe within 8 weeks, we need to get these annotations, at least the first version of it done. Okay, so just keep this in mind, and make sure you will be able to finish the workload. Okay. Um, so the junior pathologists, they will have the same workload as the non-pathologists, but given that they have some experience so we define a junior pathologist as someone who did not finish their second year of residency. So they're already in an anatomical pathology residency, but they haven't finished their second year. Okay. And these can annotate non-standard nuclei, for example, things like macrophages or mitotic figures, unlike non-pathologists who will mainly focus on the core classes: tumor, lymphocyte, plasma cells, and just other exclude classes. Okay. Junior pathologists can also help answer questions on the group, and they will get extra recognition for that. We really appreciate if you have a pathology knowledge or a pathology experience in a residency, for example. We would really appreciate and would really give credit for you going the extra mile, answering questions from non-pathologists on the group or other members on the group, participating in the discussions, and that would be extremely nice of you and superb if you could even correct annotations, correct other people's annotations through a systematic way that I will mention later. But this is what you get as a junior pathologist, or these are some opportunities that you have as a junior pathologist. Senior pathologists, we know how very busy you are, and we also need you for kind of a different type of task. So for senior pathologists, you will not be asked to annotate any course set. You will just be asked to annotate the evaluation set, again, just so we can probe the interparticipant discordance. But we expect you to respond to questions on the group, review and add nucleus labels, for things that are done by the non-pathologists and maybe even the junior pathologists, and maybe also annotate some of the kind of rare or non-standard classes like mitotic figures like macrophages, endothelial cells, etc. Okay, so senior pathologists kind of have a more supervisory role. Junior pathologists make primary data but may help with the supervision if they want. Non-pathologists are the majority of the people in this study, and the majority of data is going to be created by the non-pathologists. Okay. All right. So that was the quantity expectations. Now we talk about the quality expectations. Now, please make sure you use a mouse, okay, or a tablet. And a tablet is not even preferred. Please use a mouse. That is the preferable way to do it. The ergonomics, your comfort, your being in a comfortable position, using a comfortable screen, is extremely important in guaranteeing quality of the annotations, okay? And remember that what you're doing really is you're generating data that algorithms are going to be using to learn how to do what you are doing manually but automatically. Okay, so if you tell the algorithm this is what a tumor cell looks like, and your quality is good, of the quality of your data is good, then the algorithm is going to really learn the correct rule, right? So it's very similar to human learning. If you give garbage data or if you give poor quality data, the learning is going to be bad, right? So if you teach, if, for example, if you're in a residency program and you don't teach your residents correctly, then of course they're not going to turn out to be great pathologists. So this is the exact same idea, except that computers are a little, or maybe much dumber than human beings are, and therefore there really is not a huge margin of tolerance for poor quality. So please make sure the annotations are appropriate quality. This will help us get this data and this paper published. This will help us make some interesting analyses and correlate it with things like outcomes and gene expression and whatever it is that we decide to do with this data. It will also help other people who use our data get useful results. Okay. And the study coordinator, myself as well, along with some of the senior pathologists and Dr. Lee Cooper, my advisor, we will be judging the quality of your annotation through a combination of expert review, right? So this is the course set. How many corrections did we have to make to your annotations to make them of good enough quality? Um, um, just general probing of the quality of your annotations and so on. As well as we're going to be comparing your annotations with everyone else's on the evaluation set, and that kind of gives us a feel of where you stand in terms of the how good your annotations are. Okay. Now, accessing your slides. So I'm going to go through a tutorial where I actually go through the website with you step by step. But for now, let me just show it through this PowerPoint, okay? So step 0, and this is the very first step. You have to do this. And please feel free to have this video, on the side while and follow these instructions as they happen. Or I'm also going to upload this PowerPoint presentation for future reference so that you can kind of follow these instructions one thing at a time. The first thing you need to do, and you don't need to do this every time you do annotate, you just need to do it the very first time, like right now, okay, is you go to your Google Chrome, which is the browser that we're going to be using for everything, and press Control H, and then clear your browsing data, especially the cached images and files, okay? Now this is very important, and honestly, not just cached images and files, but also browsing history and cookies, okay? So you need to clear cached images and files, but you also need to clear cookies and history. So if you can clear everything, that would be perfect. The reason that is important is that especially if you are continuing from, if you were with us during the previous version of this, the region annotation, then you will have annotation styles stored in your browser. You're going to have, the old version of the Histomics TK and the digital slide archive interface, and these may really collide with the new updates. So this is very critical. Please make sure to do this before you go on and you do anything else, okay? Now, after you clear your browsing data and cache, this is the website where we do all the annotations. Now, you already know this from the previous version. Just candigram.neurology.emory.edu, port 88, and then, Histomics TK, okay? Now, if you were with us in the previous version, you already have your login credentials. You already have an account. If you don't have an account, then please make a new account. Let me know what the account is and what your username is so that I can add you to the group that have access to our project. Okay? And then you can open your folder. There's a icon, called open image. Then you go to brick analysis, BRCA analysis nucleus, annotation portal, and then you pick your specific folder. So I'm going to go through all of that, but for now, please, this is what you need to do. All right. Now, again, this is the website that you need to go through to make the annotations. And then again, you can either register or log in from here, and then just enter your login and your password. If you're a new user, you can just click on register here and make it new. Please don't create a new account if you already had one. Just use forgot your password functionality. Okay. All right. So once you log in, you can see here I logged in as someone called Motag, which is basically a generic user that has exact same access as any of you guys. So what you will see is after you log in, you click on Open Image in here, and then you will see a drop-down menu. Click BRCA Analysis Nucleus, and then Annotation Portal. Okay, BRCA Analysis Nucleus, and then Annotation Portal. And then when you click that, you will see a list of folders with different names. So find your name in these. If your name is not here yet, let me know so I can add it. Basically, we have space for 30 participants because that's how much data we want to gather. So, we need about 130-ish slides. Can't remember the exact number. And, when you divide that by the number of slides per participant, that's basically 30 participants, okay? Now, we have so I just made generic numbers for the participants, but I added the names of people that joined the project so far. Again, if you don't find your name, just let me know and I'll add it. Then, once you click on your name, so here I clicked on the name of Ru'aya Sar, who in fact was the very first person to join this new project. Very proud of her. So you will find that you have 4 folders. If you're a non-pathologist, you will have a core set. Okay. Everyone else, sorry, non-pathologists and everyone else, everyone will have 3 evaluation sets. Everyone will have evaluation set 1 and evaluation set 3. Evaluation set 1, if you remember, is the one where you actually are making new annotations, not correcting annotations made by the computer. You're actually making annotations from scratch. Evaluation set 3 is annotations created under one experimental condition. Okay? And then different participants will have either evaluation set 2 or evaluation set 4, but not both. Okay? So basically, you will have 3 evaluation sets. Evaluation set 1, evaluation set 3, and either evaluation set 2 or evaluation set 4. Okay? Now, you will notice that I'm kind of blinding you to what these evaluation sets are, or what experimental conditions resulted in these. And this is kind of done on purpose so that we don't bias you to tell you, okay, this algorithm is better than that algorithm, or so on. So we need to kind of validate what things are better than others, okay? So you don't get to know what these things mean. The only thing you really know is that all the evaluation sets except evaluation set 1 are corrections. All right. So now let's click on. So now we clicked on the core set, and you click on the slide, and then you will see that it appears here. You see the word selected item, and then you click open. So when you click open, this is basically saying, all right, I'm going to annotate the slide. So once you've done that, what do? Once you've done that, and you click open, you will, you'll open the slide. Now, before we start doing annotation, here's something that needs to be done once, but it's very, 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 very important. What we need to do is that we need to define all the annotation styles so that they are stored in your browser. This only needs to be done once. You can do it now, right after you finish this presentation, and then you don't have to worry about it ever again. So what this does is you will be defining, for example, saying tumor is red, it has a thickness of blah blah blah, the lines look like that, and so on. So you will zoom in to an area completely outside any field of view, just a random area, and then you will kind of define the different styles, and then just place a dot anywhere. Okay. So basically, this basically is you're kind of like creating one annotation from each type, and along the process, defining these styles and saving them in your browser. Okay. Again, you only need to do that once, and I will kind of show you, what I mean by that in a little bit. Okay. So this is very important. Please, please, please make sure to do that first. Okay. All right. So here's a slide. Let me kind of introduce you to the kind of the structure or the anatomy of the interface. So the first thing you want to do is you want to look at the fields of view alone, just looking at the fields of view. Now, this is a core set, which means that it contains a lot of small fields of view. So I think just given just back of the envelope kind of calculation, one of the core set slides will take you around 1 day of work. So maybe anywhere from 2 hours to 4 or 5 hours of work, a maximum, of course. It could be less than that, it could be more than that. Sometimes the computer annotations are very correct, so you barely have to do any work. But it really depends. So, this is going to take a little bit of time, which is why you only have to do 5 slides in the core set. So if it takes you even 2 days per slide in the core set, that's just 10 days of work to finish your core set. And then for the evaluation set, you only have 6 of these squares per slide, so it's like nothing. Okay. So for the core set, don't feel overwhelmed by the number of FOVs because you only have a limited number of slides that you need to do. But again, the first thing you need to do is just click on the eye, make sure you see these fields of view, just know how many of them, where they are, what their colors are, and so on. Now you'll notice that these fields of view have different colors, these FOVs, and these colors, don't worry about what they mean. These are basically cues that I used to pick these fields of views. They were picked automatically, but based on some objective criteria that I set. And basically, the yellow ones were picked under certain criteria, the white ones under other criteria, and so on. Okay, so don't worry about what the colors mean. Just know that if it's a field of view, then it needs to be annotated. Okay. Then you want to zoom in and zoom out, just kind of familiarize yourself with the slide, and then once you are familiar with where everything is, then you want to click on the eye icon. You see the eye icon here? You want to click on that, and this is going to display. If you remember in the previous slide, we clicked on this eye icon under FOV, right? And this will show only the fields of view. Whereas if you click on this eye icon, the one at the top, this will show all the annotations in the slide, all the computer-generated annotations in the slide. And you can see there's a lot of them. There's just so many of them, all right? Of course, you're not going to correct every single one of them. That's why we have these small fields of view that you need to correct, okay? These computer-generated annotations. Now, one thing you need to do just for your own convenience and for really making sure that you make accurate annotations, go to the slider bar on the left here and make sure to reduce it almost to the minimum. If not to 0, then maybe to 10 or 20%. This basically just reduces the transparency of these computer-generated annotations so that you can kind of see the underlying tissue. You can really see what is going on under these colors. And that turns out to be important, as you will see in the tutorial later on, and as I zoom in on some of these snapshots, okay? Whenever you're in doubt about the underlying structure, if this is not enough, then you may reduce even this bar. So this slider on the left kind of reduces the transparency of the fill transparency, okay? While this one kind of reduces the entire annotation layer transparency. It may sound confusing now, but when you try it, you'll know what I mean, okay? All right. So how do so what do you do? First of all, let's say you picked this yellow FOV. So here's the slide. We're zooming in really as much as possible on this small field of view. Now, please make all your annotation at the maximum zoom level, okay? So you can see over here the zoom level is 80, all right? So just go to the maximum. This is the only way that you'll be able to really see every detail and really see the nuclei. So zoom into the maximum level, and then click New. And then after you click New, put the name of the annotation group. So this is not the name of this or the style of the annotation. This is basically a grouping of annotations. Okay, and you want to do it first name dot last name underscore nucleus type. So for example, in this case, it's Rukaya dot soccer underscore lymphocyte. Okay, so first name dot last name underscore the label. Okay, so inside this annotation group, you're going to save all the lymphocytes. If you want to make tumor, then you make a new folder or a new annotation group, and you call it Rukaya dot soccer underscore, let's say tumor, for example. Okay. So, yeah, I think this is clear enough, and then you click Save. When you do that, you will see this kind of window, if you will, or this panel appear. Now, this panel is basically contains, the annotation group. Now, it's empty for the moment because you haven't created any annotations. So what you want to do is pick the annotation from the drop-down list here, or if you haven't already defined the annotation style, you can define it by clicking on this gear icon and adding the annotation style. Now remember, we already said in a previous slide, and let me go back there, that you should have defined all the annotation styles ahead of time. So really, you should not have to click on the gear item at all. You should have all the annotations visible in the drop-down list, since you've already defined them at this step. But for having a smooth presentation, I'm just going to show it as if you're creating an annotation from scratch. This is also relevant for the senior pathologists who may need to create a new annotation style that is not really defined in the main document. But for everyone else, really, you should have the annotation predefined from the previous step. Okay. So, how do you define an annotation style? To define an annotation style, you click on this gear icon, okay? And when you click on that, you will see this window pop up. This window contains the style, the color of the different of the specific annotation that you want to do. Now, this is very important. One of the most important points in this presentation. Go to the guide document and make sure that you copy the style exactly as it is into this document. So, what does the document look like? Let me show you. So this is the Nucleus annotation standards document. This contains basically kind of a written set of rules. Some of them are mentioned in the presentation, some of them are not mentioned in the presentation. But basically, you really want to read through this and know what's in it. Now, to hammer the specific point that I'm talking about, here is the style. This is the same. See this one? This is the exact window that we saw here. So this one contains things like group name, label, line width, line color, and fill color. So for example, for tumor, and then you look at this table and you use this table to fill in that prompt window. So, and, copy this as is, tumor. Um, so forget about this column for now. So tumor, copy this. This is the color. So this is red, green, blue, RGB. So copy this whole thing in the line color place. Copy this fill color as is and put it over there. Copy the line width, and that's important because it's going to help really make your annotations different from the computer annotations. They're going to kind of stand out if they're thicker. Okay? And do this for all the classes. So there's tumor, there's lymphocyte, there's plasma cell, there's fibroblast, and there's unlabeled. And these are basically the 5 standard labels that everyone should have. So almost every nucleus in the data set is going to belong to one of these 5 classes. Tumor, again, lymphocyte. Plasma cells are actually quite rare, so most of the time, if you're in doubt, it's probably a lymphocyte, all right? This is a plasma cell is kind of rare, but if you see it, label it, okay? Fibroblasts, and if you're not sure or the nucleus itself is not possible to be labeled, just using H&E, then give it an unlabeled label, okay, if you will. Like the label itself is called unlabeled. Don't leave it without adding anything. Add the label called unlabeled. Does that make sense? Like copy the word unlabeled itself in the annotation style. There are non-standard classes for the junior pathologists and the senior pathologists, like mitotic figures, macrophages, or endothelial cells. So these are also things that you may want to annotate. But for the non-pathologists and actually for everyone, these are the 5 key classes. Again, tumor, lymphocyte, plasma cells, fibroblasts, and other or unlabeled or vague, whatever, right? But use the exact same words here, exact same colors, exact same line thickness as in this document, okay? Now, like I said, the computer will have its own predictions that you want to correct. So this is what the computer prediction looks like. A tumor prediction, what the computer thinks is a tumor nucleus, is going to give it a red color and is going to, like a red boundary. What it thinks is a lymphocyte is going to give it a blue boundary. What it thinks a plasma cell is kind of cyan. What it thinks is a fibroblast is green, and everything else is like black. You will notice that your colors are actually going to be similar to the computer colors, but they're a little bit different. And they're different for a reason. They're different just so that you can clearly see what is generated by the computer and what is generated by you. Okay, so getting back to the presentation. So you will copy the styles exactly as they are. And again, you should have already done that in this step where you defined all the styles and kind of just made random annotations here and there, just random points. Make sure the styles are stored in your browser. And in that case, you wouldn't have to click this gear icon. You can just, you'll find it in this drop-down menu. The next thing is you want to start correcting the computer annotations. So in this case, let's look at this field of view. Look at these. There's here, this is probably a lymphocyte. This is probably a lymphocyte. Actually, let me grab the pointer. Oh no, this is terrible. Okay, so this is a lymphocyte here. This is clearly a lymphocyte, clearly a lymphocyte. So if the computer is correct, both in terms of the label and in terms of the nucleus boundary, then you place a dot with the correct label inside that nucleus, right? So this is what we did here. This is, we use the point and we say, okay, this nucleus is correct, 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 and you just keep placing dots on things that are 100% correct. Basically, they're correct in terms of the label, they're correct in terms of the boundary, okay? And if you're not sure, oh, maybe is this boundary correct, maybe it's not, just feel free to reduce the transparency, okay? Now, the next stage is you click the rectangle. And in here, you look at things where the computer is either incorrect in terms of the boundary or it completely missed that cell. So in this case, look at here. This is the lymphocyte, but the computer missed it. This is a lymphocyte, but these are two lymphocytes that the computer missed. This is two lymphocytes that the computer thinks are one lymphocyte. See, it places one boundary around it. So what you do is you place a rectangle as tightly as possible around it. Okay, don't make the rectangle too large or too small. Just make it exactly, to the best of your ability, of course, around that cell. So, rectangle here, rectangle here, rectangle here, rectangle here, rectangle here, rectangle here, and so on. Okay, so now you can see, right? This is this is important so that when I use your annotations, I would know anything with a dot in it, it's correct. I can use it as is, including the boundary. But if it's not correct and I see a rectangle, then I know that, we have a kind of weaker, I don't want you, this is, instead of making you create all these circles and wasting your time, I kind of give you a head start. And whatever is not correct, I just let you make a rectangle, and that's good enough for me, okay? So you can see the rectangle here, 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 okay? And yeah, so that is the second step. And then the third step is to do that for all the labels. So you can see here that there are nuclei where we're not sure they're probably not lymphocytes. This one is like we don't know what it is. We're not sure if it's a fibroblast or if it's a lymphocyte. It is actually vague. It doesn't have the characteristics of either. And in that case, we just give it the label unlabeled, okay? And you follow the exact same convention. This is unlabeled. The algorithm didn't even know it existed, so you can just place a rectangle around it. See these gray rectangles? This one, again, the algorithm doesn't know it existed. This one, there are two vague nuclei. Not sure there are lymphocytes, but I don't know what they are, so I make them gray. Again, only use the label unlabeled if you are already confident in your ability and really are sure that these nuclei are vague. In other words, they cannot be labeled in H&E. Even by an experienced pathologist, we cannot tell for sure, right? But if you're a non-pathologist and you haven't done many fields of view so far, you're not really confident. For example, you're not sure, is this a fibroblast or is this a lymphocyte? If you're not sure and you're not experienced, don't just label it as unlabeled. No. Go to the group and ask. And only after you've done this for, a few fields of view, maybe at least 10 fields of view, and you're comfortable, you know what a lymphocyte looks like, you know what a tumor cell looks like. Only when you've done that, then you can label vague cells as unlabeled, okay? So this is very important. We don't want to escape from labeling things just because we're not experienced. But if we are experienced, for example, you're a senior pathologist and you're saying, you know what, I really can't tell. I really need immunohistochemistry to know this, right? For example, so if the nucleus really is hard to tell and really cannot be told from H&E, then you use the label unlabeled, okay? And yeah, I guess that's it to this point. Now look at this nucleus, for example. This one, the algorithm thinks it's a lymphocyte, so it gave it a blue outline. The algorithm got the boundaries correct. So what do I do in this case? Well, I place a dot. I place a dot because the boundary is correct. So I'm saying the dot. Whenever you place a dot, it means the boundary is correct. But the dot has a different color. The dot has the label unlabeled. So basically, I'm saying here that even though the boundary is correct, the label is not. Okay, and the label is unlabeled essentially. Okay, so you want to do that for different classes, for tumor, for plasma cells, whatever. Okay. So that's kind of the workflow that you're going to be following while annotating these things. Now, let's say you're done. You can see all our annotations in this field of view are really crammed in here. You see all these dots. So, you're done with this slide. You want to go to the next slide in this folder. Then you can click this next button. This will basically take you to the next slide. Or if you, want to just move randomly between slides and don't want to move in order, you can go and open image in here and then click, the next slide that you want to annotate. So you can do it either way. All right. So now that you kind of have a general overview of what, how to access your slide and what to annotate, let's go through some rules. Number one, please only annotate inside the predefined fields of view, right? There's a reason we pick these fields of view. There's a reason we put them in these locations. Also, you're going to be making your job a lot harder if you annotate outside, okay? Because you still have to finish all your fields of view, right? So anything you do outside is going to be extra work. So only annotate inside the the square fields of view that we give you. If a nucleus extends beyond the FOV boundary, make sure that your bounding box covers the full nucleus boundary. Right? So I'm going to go through the document and show you some of these rules, so don't worry about this for now. Make sure that each FOV is complete before moving on to the next field of view. So this is an important point. Make sure that you finish one thing before you move on to the next. Don't randomly annotate nuclei from the, so for example, don't annotate some nuclei from here and then move on to some nuclei from here and then to some nuclei from here and then to some other nuclei here. Don't do that. That is incorrect. That is just a very that is really going to be detrimental and going to degrade the quality, and it's going to be hard for you to know when you finish the field of view. So what you really want to do is want to go through one field of view at a time. Make sure it's finished completely and you're comfortable with it. Then go on to the next one. Okay. And again, it's very important that you do that. Make sure there are no missing annotations for the. It's very easy to miss nuclei in this schema. Even the computer misses a lot of nuclei. So please make sure that you annotate every single nucleus that you see. If the nucleus is vague, don't leave it. Label it as unlabeled. Okay. And please, please, please don't annotate things in random order. Annotate the core set first. You have to annotate this first. Then the first evaluation set. Then evaluation set number 2 if you have evaluation set number 3. Then eval set 3. Then, if you have, evaluation set number 4. Again, everybody will have evaluation set 1 and 3 and either evaluation set 2 or evaluation set 4, but not both. Okay? After you annotate your first field of view, don't keep on going and annotate new ones. Take a screenshot, share it on the Slack group, and wait for the approval and comment by one of the senior pathologists or the study coordinator, myself. Okay? Do not annotate anything other than that. So after you finish your first field of view, don't annotate anything until you get our OK. Now this is for your own benefit, because if there's a systematic problem, for example, you're always mislabeling things, or your bounding boxes are always incorrect, or you have a misconception about what a lymphocyte is, or whatever. If you have a systematic error and you keep on annotating things quickly without getting any feedback, then we'll tell you, that's an error. Then you have to go back and correct all of this. So that's a waste of your time. So what you really want to do is you want to do your first field of view, get feedback, and then once you get our OK and you're sure that you're doing things correctly, to go on and continue. If you're unsure about anything, just like we did the previous iteration of the project, take a small screenshot. There is an app or there's something called the snipping tool on most Windows computers. So there's something equivalent in Mac as well. So if you search snipping in here, you'll see a snipping tool, and then that basically will help you not take a full screenshot of the entire screen, but basically like a small area of the screen. Now that app it comes with Windows 10, so you don't have to install it or anything. It's like Paint. It just comes with Windows. So if you've never used it before, please, this is what you need to use to take screenshots. And yeah, make sure to use it, okay? Again, if you're unsure about anything, share it on the group. Wait for our feedback. Yeah, all right. So now let me just quickly show you some of that stuff. So here we go. We go to Histomics TK. There we go. Candigram.neurology.emory.edu. Histomics TK. Now you can see I'm already logged in as Motag, but you're gonna log in. Then you go to Open Image, and then you go to Bracket Analysis Nucleus, Annotation Portal, and find your name. So for the purpose of this tutorial, and to thank Rukaya for being the first person to join the new group, we're gonna annotate one field of view for her, okay? So you click on the slide. So after you, again, see what we did. We clicked on Annotation Portal, click on your name, click on core set, or whatever you want. But again, you need to do things in order. So we start with the core set, and then you click on the slide that you want to annotate, and then you click Open, okay? So after you click Open, first thing you want to do is kind of have a general field of where the fields of view are. So you click on this one, and then click on the eye icon. Now you will notice that all of these have become open. So the fields of views, these folder names show groups of annotations, while these ones just show the styles of annotations. So it's a subtle difference. I'm not going to go into that. But anyways, so after you click on this eye icon, this will kind of show you where the different fields of view. So you can see Rukaya has, I don't know, that's maybe 20 something fields of view, 30, something around, maybe 25, 30, something around those lines. So these are the fields of view that Rukaya needs to annotate for this particular slide. And then now that you have a feel of where the fields of view are, now you can just click on this eye icon, which is going to show everything. Now, after you click this eye icon, it's going to take a little while to load. Don't worry, just wait a little bit, because now the computer is loading all these annotations that the algorithm has created for you to correct. And that's going to take a little bit. It's not going to take very long, honestly. It usually takes a few seconds, maybe 6 seconds or 7 seconds if you have good, high-speed internet. If your internet's slow, it may take longer, maybe up to 15 or even 30 seconds. That's okay. Okay. So now we zoom in. We zoom into a field of view, and here is the field of view that Rukaya has, that we annotated and I showed in the tutorial. But remember, before you do any annotations, before you do anything, what you need to do is define all the annotation styles. And again, this needs to be only done once. So the way I'm going to do this is I'm going to just go somewhere completely random, completely outside the field of view, and then define all the styles. So how can I define the styles? It's easy. You are going to make this window, make a smaller version of this window, right, like this, okay, like this, and you're going to open the annotation document, the annotation style document, which I already showed you earlier. So you open that like this. There we go. Okay. And now we create a new annotation document. Just wait. Oh, great. My computer can't handle this. It's so slow. Oh. Yeah, I'm doing this recording on my old computer, which is like just super slow, but it's the one where I can record. But anyway, so what you need to do is go through this document, and like I said, fill in these styles. And the way you want to do it is, sorry, let me reload this. Just a second. Okay, so what you want to do is click New, let's create a new style. Just a sec. So normally, that's why it's actually important to have a good computer and a good internet connection. This is just caused by the fact that my computer is kind of an old computer, but normally it shouldn't happen, okay? So don't worry about this. So what you do is you just, let's create a new document. And again, Rokaya, first name dot last name, and then underscore, let's call it random, okay, or temp. Let's call it this way, temp. And this is, so now, right now I'm not doing anything. I'm just defining the annotation styles. So you can see now, I have this. So I'm going to create an annotation style, and then I'm going to say this is tumor, and then tumor. And then I look at this document and it says tumor has this RGB value for the line color. So I go here and I fill this and I fill this, and I think it had an 0.1. Oops. RGBA, right? And then the line width for tumor was 4.6. Actually, it's 4.6 for everything. All right, and yep, this looks perfect. So now that I have this defined, I click Save, and then I go here and I check tumor. Where is it? Did I really save it? I don't think I saved it. Very stupid of me. So see, that's why I said you need to clear your browser cache. If you clear your browser cache, you wouldn't have all of that old styles. I have all of these old styles in my browser, and I unfortunately didn't clear my browser cache. So if you did, you wouldn't have to deal with this. Anyways, so let me just quickly do this again. Tumor line width 4.6, and then this is the line style, line color, and this is the line transparency, right? 0.1, and what is 0.1? Yep. And we say save. Now we click on tumor, we choose it from the drop down menu over here, and we make a point. Okay, again, you only need to do this once. You wouldn't have to do it any other time. You just do it now, and that's it. You wouldn't have to worry about it again. Now let's find the next style is lymphocyte. So let's create a lymphocyte class. Go like this. We click lymphocyte. Actually, it's better to just copy paste it to make sure the spelling is absolutely correct, exactly correct. The line width is 4.6, and this is the fill color. Okay, sorry, this is the line color, and this is the fill color, and 0.1, and this is RGBA instead of RGB. So basically, you just copy it from here. Okay, and you click OK, and then you place one dot. Sorry, that's wrong. You need to make sure you click it from here. My goodness, it disappeared. I think it didn't save. I think what's happening right now is that the database is updating while I'm doing this. so it didn't really save or because my computer is super slow, which is actually more likely. It's because this laptop is the old laptop. Anyways, you wouldn't have to face any of these issues if you have a good laptop, or even an okay laptop. This one is just super old, but I have to use this because this is the one that has the recording um, software. Okay, unfortunately. So yeah, now it shows lymphocyte, and I can click it, and there you go. Now the next one is uh, fibroblast, for example. Okay, so you go here, and then you click this one, and then fibroblast. You can see I already have it, but I think the colors are different, so let me make sure they're correct. Okay, so these are the colors of fibroblast 0.1. There we go. Now if I click fibroblast, I have that. Now, so now I already did 1, 2, 3. I still have plasma cells and unlabeled left. So let's do that actually now that so that there's only a handful of styles that I need to define. So let's do this. So plasma cells, there we go. Plasma cells. Let's copy this here. 4.6. Let's copy this. There we go. Here. Paste it. Paste it. 0.1. A. And now this is plasma cells. Anyways, you get the idea, okay? So after you do this and you define everything in here, all the styles, and you place a dot for every style, now you are ready to actually do some annotations. So you zoom out completely, and then you can see where we place all the dots in here. And then you click the eye icon so you can see your fields of views and corrections and whatnot. And now just wait a little bit for everything to load. All right, let's wait. We have nothing to lose. Let's just wait. So when you're doing actual annotations, everything will be faster than this. The reason this is slow is many things. One, I'm using an old laptop. Two, I'm having Google Documents and Google Sheets and a recording software all running in the background. Now, these are all very heavy things, especially the recording software. It's very heavy, okay? Which is called Wondershare Filmora, in case anyone is interested. And of course, the Google Sheets is very heavy with lots of things. So, you wouldn't have any of this lagging and slow kind of performance if you're doing this with Google Chrome, just one tab, without any background programs running, okay? But I'm facing all this kind of lag because, it makes sense. I'm just running so many things in the background. But anyways, I'm still going to show you how to do this. So let me let's wait a little bit for this to load. Or maybe actually let me close one of these so that it's quicker. And do this, close, let's reload. Perfect. Just a second, let us reload. May take a little bit, but okay. Now we zoom in. Zoom in. Oh, great. Hold on a sec. Sorry. I know it's taking a while, but I'm determined to show you this in real time, so please bear with me. So, I mean, you have access to the video, you can kind of just fast forward this bit. In any case, let's just wait a little bit and let us zoom in a little bit. Okay. By the way, if you want to zoom in quicker without having too much lagging, you can use these. These are actually better to use when you're zooming in than using your mouse scroll. Um, so anyways, so let's do one field of view for Rukaya. Again, let's do it at maximum magnification. Now you can see the transparency is very, very high. You can't really see the underlying cells. So let's reduce this to almost a minimum, okay? Actually, I like to reduce it to 0. But you may have different preferences. Maybe you want it a little bit higher than 0. So what you're going to do is you're going to create new, and then Rukaya underscore soccer lymphocyte. Actually, I already had this created, so I'm not going to create it new. I'm just going to find the folder called Rukaya underscore soccer lymphocyte, which should be here. Oh, no, it's not going to be a folder. It's going to be now, yeah, look at that. Rukaya underscore soccer lymphocyte. This is where all the lymphocytes are stored, okay? Because what this shows is the style, like lymphocyte, not the group of annotations. You can do this, or actually, technically, you can make a new one, no problem. You can do this soccer lymphocyte. You can create as many of these as you want, no problem. Okay, so now we have a new group. Let's pick lymphocyte and click the point. Now, because we've already defined the style, when I click lymphocyte, if you look at this, you will see that it has everything already defined because I did the initial step of placing the points at the beginning. Now let's find nuclei where the algorithm is correct. So this nucleus is correct. This one the algorithm is correct. This one, oops. So if you see that I created this one by mistake, you just right click, and then when you right click, you can actually get the option to delete this annotation, which is great because in the previous version of this we couldn't really delete things. So click here, click here, click here, click here, right? Click here, click here, click here, click here, click here. Let's actually finish one field of view just to show you that it's actually pretty quick. You can really quickly finish one of these things. So I'm going to finish it in a couple of minutes while you're with me on this. So what I'm doing now is finding nuclei where the algorithm was correct, both in terms of the label and in terms of the boundary. So all of these are correct. These are correct. These are all lymphocytes that are... This one, you can see the algorithm kind of clumped them together. They're actually 2 lymphocytes. So in this case, I can't place a dot. What I do is I place a rectangle around each nucleus. So this is one lymphocyte, and this is another lymphocyte right here. Okay? Now let's go back to the dot and find any other. This one is kind of vague. I don't think it's a lymphocyte, so I'm going to leave it out for later. Let's click this one. This one's correct. This one's correct. This one's correct. This one's correct. This one is correct. Look at this one is overlapping, so you don't want to place the dot here because then I will be confused whether you mean this big one or the small one. So try to put it here, kind of at the edge. I think these are okay. This one is also correct. This one is correct, but it's kind of tricky, so I can't really place the dot anywhere. But I can put it here, which kind of just shows this part of the nucleus. This one is correct. This one, I think this is a lymphocyte. Yeah, that works. This one is correct. This one, nope. This one is correct, no problem. Okay, so you can see that all of the lymphocytes where the... Okay, this one I missed. All of the lymphocytes where the algorithm was actually correct in labeling, I got them. Now, let's find lymphocytes where the algorithm didn't really get the boundary correct. So now let's put all the rectangles. So you can see there's a lymphocyte here, there's a lymphocyte here where the boundary is just completely wrong. There's a lymphocyte here, there's a lymphocyte here. So what you want to do is you want to grasp the full extent of the cell of interest, right? So also you don't want to be too large though, so you want to kind of be exactly at the boundary or exactly at the size of the cell. So over here you can see this one. You can see this one is a lymphocyte, this one is a lymphocyte here, this one is a lymphocyte here. This one is actually a fibroblast, so I'm going to get back to it later. So let me just label all the lymphocytes first, okay, and then later on I'll show you how to, what to do about these. So this one is actually, this was correctly done by the computer, so let me delete this rectangle that I did. Never mind. Okay, let's just keep it. Yeah, it's just because I'm doing all this recording, it's just a little slower than it usually is. So you can see this clump. The algorithm thinks all of these are one lymphocyte, but in fact it's 3 of them. So you just, break it down. You ignore what the computer does, basically, in these situations. In here, you do this, you do this. See that? There's no problem. You just do this, and then let's do this. This is a lymphocyte. This is a lymphocyte. This is a lymphocyte. This one, I think I already labeled it, but anyways, this one is a lymphocyte over here. This one is a lymphocyte over here. You can see that. This is a lymphocyte over here. This is a lymphocyte over here. And then you can see there's 3 of them here, so let's do this. 1, 2, 3. There's one here. There's one here. And there's one here. Okay. These are 2 lymphocytes that the computer kind of thinks are 1, so let's do those. Let's break up this cluster here, so let's do it. Alright, let's just finish it. So the reason I want to do this is just to show you kind of the expected time. So this is a very dense area. Usually things are much less condensed. Usually the lymphocyte areas are the ones that have a lot of cells. Normally it's less than that. But this is kind of just to show you. Actually, this one is correctly predicted by the algorithm, so let's put a dot. This one is, these are clumped by the algorithm by mistake, so let's place rectangles. Now, look at these other cells. These are fibroblasts. So what I need to do here is go to Rukaya Soccer fibroblast, which we don't have. So let's create another annotation group and call it Rukaya Soccer, and instead of lymphocyte, we call it fibroblast. Fibroblast, okay. And say okay. And then now we pick fibroblast, which we already defined. And look at this. This one is, well, I'm not sure about that, but this one is a fibroblast over here. Look. So just give it the label fibroblast. And then let's look for others. This one is missed by the algorithm, and it's a fibroblast. This one is probably a fibroblast. This one is unclear, so I'm going to give it the unlabeled label. This one is vague. This one is actually probably a lymphocyte. So I go to Rukaya Soccer lymphocyte again, and then pick lymphocyte, okay? And I just say, this is a lymphocyte over here, and this is a lymphocyte over here. Now you will notice that there are some vague cells. So these were fibroblasts, but these are kind of vague. This one is vague. This one is vague. I don't really know what these are. This one is vague. So what I do in this case is I go to Rukaya Soccer unlabeled, which I already have, right? So Rukaya Soccer unlabeled, and then I go to did I define unlabeled or not? I think I did. If I didn't, let me define it now. So let's do this, and we say unlabeled. Let's make a new one. Unlabeled. Let me just copy it from the, I removed the document. and this is 4.6, and then let's find the document. So let's go to the annotation protocol and find what the unlabeled, oh, not this one, sorry, wrong Google document. So let's go first to the crowds and let me find annotation, and then let's go to Nucleus annotation and Nucleus annotation standards. That's the one that that's where we have all these colors and whatnot. So you go down to unlabeled. Okay. Let's go down to unlabeled. Just bear with me a little bit. And okay, let's go up, up, up. There we go. So let's copy this. Okay. Copy. And go back here. Oh, great. Yeah, we can't really have the Google Doc work with this. Okay, so you get the idea. Okay, so you just get how this works. This thing is just gonna keep. Okay, let's give it one more try. Just for the sake of completion, just showing you what a full field of view looks like. Let me close this. Let me memorize this. 128, 128, 128. Okay, close, close. And let's get this again. Okay, let's just reload this area over here. Okay, wonderful. So now let's view all the annotations. Okay, and yeah, look at this. We actually just created this field of view containing, lymphocytes and fibroblasts and unknowns and everything, and we did the whole thing in maybe, I don't know, 10 minutes, 15 minutes. So it's not very difficult. So again, unlabeled. Let's go to Rukaya Soccer unlabeled or Raya Soccer unlabeled, and let's pick. Oh yeah, let's define unlabeled. So again, let's go to unlabeled. There we go. Unlabeled 4.6, and then this one, I remember, 128, 128, 128, 128. Let's copy this. Let's paste it here. RGBA instead of RGB, and then here it becomes 0.1. Okay, so this is for the vague nuclei. So look at this nucleus. Which one? There was a couple of vague nuclei here. So this one is unclear. I'm not sure. This is bigger than a lymphocyte, but it's also not a fibroblast. So let's give it unlabeled. This one is unlabeled because it's vague. I don't know what it is. I mean, it's vague. I think it's objectively vague. This one is vague. This one is vague. It's not clear what this is. See this one in the background? This one is vague. It's hard to assign this a label. Yeah. So there you go. That's the full field of view with every single nucleus annotated. Now the nice thing about correcting computer annotations is that a lot of these things we just placed a dot. So that's basically the premise of some of these experimental conditions. Okay. So that's the take-home point of why we're doing this. Now now that we did this, let me close Histomics and quickly walk you through the guide document. You've already seen almost everything in that guide document, but let me just walk you through some special situations, and once we're done with that, that will be the end of it. So is go to the nucleus annotations, and this is the standards. Of course, you have the link to this document, so um, um, so you can access it. So these rules, we've already talked about them. They were at the beginning of this presentation. Now, what I want to walk you through is this. So this is just some troubleshooting thing. So what if it takes a long time to load, like you've seen with me here? First thing you need to do is close background applications, right? So in this case, it's in my case, I'm running a video recorder in the background. I was having Google Documents and Google Sheets open. All of background applications are going to make your video, I'm going to make your Histomics TK very kind of slow. They're going to make everything difficult. So close background programs. Make sure you're using Google Chrome and not other browsers, and so on. And if everything else fails, then your internet connection is probably poor, and you just want to move to the faster connection. Now, so what do you do when the algorithm correctly predicts both the boundary and the label? You place a dot. And I think I've convinced you through many examples that this is an easy process. Okay, so and you place a dot with the correct label. So these are lymphocytes, you place a blue dot. These are tumor cells, you place a red dot. Okay, so the algorithm correctly predicts the boundary, but assigns an incorrect label. And in that case, you place a dot, but you make sure that the dot has the correct color. Okay, so here the algorithm thinks this is a lymphocyte, but it's actually a tumor cell, so I place a red dot in here, and the same here. Okay, so no problem. Okay, the algorithm correctly predicts the nucleus boundary, but assigns an incorrect label, but you don't actually know what the correct label is. Okay, so if you are new to this, then and you're not sure, then you can take a snapshot, put it in the group, and ask. If you're not new and you know what you're doing, then you can use the unlabeled label, right? So we already talked about that. Okay, the algorithm incorrectly predicts nucleus boundary or completely misses the nucleus, and this is where we said you would use the rectangle. Okay, the algorithm clumps together multiple nuclei. Again, you'd use the rectangle as if you don't even see what the algorithm said. A nucleus extends beyond the edge of the FOV. In that case, you put the box around the entire extent of the nucleus. Okay, so don't stop the bounding box here. Make sure it covers the full nucleus. I cannot see the underlying tissue properly. We already said you can reduce the transparency to help with that. I know the nucleus label, but it is not in the standard labels provided. For example, it's a mitotic figure, it's a macrophage, it's an endothelial cell, etc. If you're a non-pathologist, deal as in situation number 2. So if you know what you're doing and you know that this is a vague nucleus, then give it the label unlabeled. If you don't, then ask on the group. If you're a senior pathologist, then please feel free to use some of the annotation styles in here to assign the label. Okay, the algorithm predicts 2 overlapping boundaries for the same nucleus. In that case, place it inside the correct one, and just make sure it has minimal overlap with the incorrect. But in this case, you can't really help it. They're kind of within each other. Just place it within the inner one. Okay, we've already talked about these standards. Please make sure to go through those. There are some non-standard classes for junior pathologists and senior pathologists. If you see those and you're a junior pathologist or a senior pathologist, please make sure to annotate them. So yeah, that's it for this tutorial. Thanks again for joining, and yeah, thanks for sticking with us, and we look forward to working together.